So in this session, we'll look into PyCharm as a platform or IDE for data science or machine learning projects. The first obvious question is, why PyCharm for data science? Because most of you already, if you're a beginner or even an experienced professional, will be using Jupyter notebooks extensively. Jupyter notebooks are, I would say, the most popular platform for data science project coding for obvious reasons, because you can write the code and you can see the result just below the output just below the cell. It's very interactive, as well as you can write all kinds of documentation, rich text documentation using your Markdown language. So obviously Jupyter is the standard. For example, if I want to do something like I'm importing a package pandas and I'm saying data, some package, some data, let's say breast cancer. You can see that the output is right below, and you can always go back and check the output because it is stored. And not only for the coders or the developers of this program, someone else wants to learn from this or review this or look from a business perspective, Jupyter is way to go. Right. Then the question, why PyCharm? Well, when you do a sizable projects, production level projects where you have hundreds of lines of codes, multiple files, multiple data processing pipelines, Jupyter becomes slightly inconvenient. Not only that, when you want to set parameters, run some experiments, PyCharm has more features. It's a full-blown IDE, has more features and more options to handle a production level project, slightly better than Jupyter. Okay, and you appreciate it when you learn by yourself. So in this session, I'm gonna do a small project for data science using PyCharm, explaining all the key features. And when you start adapting yourself, then you'll appreciate. We're not dumping Jupyter Notebook, because even now I use Jupyter Notebook for all kinds of exploratory data analysis or quick projects, because it's very convenient, right? But I also use PyCharm for more streamlined production client projects. So installation is quite straightforward. If you're using Anaconda platform for data science, then you might already have PyCharm installed. Right? If not, it's just search for PyCharm, go to the download section, select your operating system, Mac, Windows, or Linux. Mine is Mac Pro, and I use the community version. Well, community version is what you're going to use. It has all the features you need. Professional version has certain cool features like scientific view and stuff like that, but it's a paid version. Probably not the one. If you're an enterprise, you want to have extra features, you might go for it. So for you, community version, it's a free one, open source, right? You can download and install. Go with all the preferred settings. It will be a breeze. You'll install it in a jiffy. I already have installed it, so I'm going to go ahead and open my PyCharm. It's there already. Okay. Now open Microsoft. PyCharm. Okay. So I don't use my Mac for production projects, so I use it only for presentation and meetings. So I don't have any projects here. So when you open it, you also see very similar, a blank thing, and you can start clicking it, create a new project. Okay. I'm going to, let's say tutorial. Tutorial is a project. This is tutorial. All right, tutorial. So that's a project. You can give a name. You can see that it defaults to your user folder, and then it creates a folder in that called as projects and tutorial. This might vary slightly from operating system to operating system, but you can figure out where is the folder, and you can even change it in here if you want. Say create, and there is no directly like that. It's not empty. Oh, is it not empty? Maybe I would have already created it. I'll just go ahead and overwrite it. That's fine. Now there is already a file called main because it's not an empty folder. Okay. So let me explain you the overview, the interface of PyCharm. All right. It's very important. I'll create a new file here. I'll call this file as let's say, for example, train. So some file. Okay. So what we see here is called as editor, right? Where you write your code. Unlike your Jupyter, you cannot write rich text. You can use comment function to write quick comments on your code, but it's purely a Python code what you're going to write over here, right? This side is your project navigation. The top one is actually your directory structure. That's the folder. If you want to see the actual folder in a Windows Explorer or Mac Finder, you can simply alternate click it and say reveal. Where is that reveal? Reveal in Finder. You will find a similar thing in Windows, right? So you can go here. Oh, there's already tutorial. So you can just literally browse through it from PyCharm. I'm going to go back to PyCharm. And then you have external libraries. So you can actually go through all the external libraries of Python over here. Okay. So regarding external libraries, I would like to say something. For every project, it's always advisable to create a different environment. If you're using Anaconda, Conda environment, so where you have, it's a virtual environment where you have your own set of external packages along with the versions which are compatible to that project, all right, rather than using the same default environment, because most often when you're running a production level projects, you are using different packages. It starts overlapping or messing up with your versions, and you get into weird errors, bugs, which takes sometimes hours or days to fix. It's all because of your just not properly setting up your environment. So always start with a clean environment. How do you do the clean environment? So I'm going to close this project right now and start up a new project, completely new project. So it will be easy. I'm going to say create a new project. I'll say this PyCharm tutorial. Another tip, never use a space or anything in your file names nor your folder names, because it becomes difficult. Same thing applies for your column names in your data frames in your data science project. If the source file contains certain space or something in the column names, it's always advisable to transform into an underscore or an hyphen. It's actually underscore, not even an hyphen. So I prefer underscore. Hyphen has a different meaning. So underscore. It will be more easy for you to refer in many places. So PyCharm underscore tutorial is going to be a new project. You click open it, and here you see that there is a existing interpreter and environment. So you have to check this one, new Conda environment. All right. So what it does, okay, let me just create it. So it's going to create a new Conda environment for you. It's creating a new Conda environment, as you can see. What happens is it has created a new space for you, a virtual environment, where all of the core Python packages are already copied. And in this environment, you can actually install any external libraries. And this is only for this project. So it doesn't overlap with any other projects or the otherwise. So that's the best way of doing it. It takes a few minutes. It does consume some space, but that's a very important aspect. Okay, so I have a new folder, and if you just go and reveal it in your Finder, you will see that you have a PyCharm tutorial created new. There's no files in it. We will create some. I'm going to say create a new file, and I call this main.py, and that's where you write the code. Let me run through other things. For example, okay, so libraries. Now you have a new environment. You can actually look into the libraries you have. The site packages contains all kinds of libraries. You have not much. You have we don't even have NumPy. That's interesting. So let me just say import NumPy as np, and I'm going to simply run this. So for running this, you need to set up the configuration. Configuration is where is your Python interpreter or which interpreter. So I'm going to click configuration over here, and I'm going to click a new configuration plus symbol, and I take Python configuration, and here I can take a script path. This is a file which runs when you run the project. So I only have one file, main.py. I'm just going to give that. Everything else can be set as a standard, so you do not have to change anything. Click OK. All right. Okay, great. So let me run this now. And it says that there is no NumPy package, because you can also see from the site packages there is no NumPy package. I'll show you how to install all of these things. For now, so this is the navigation area and this is the editor. And if you want to change the look and feel of your PyCharm, like you want to change the font size, color, background color, or the font of this one, all of this can be done by going to PyCharm and preferences. In Windows, it will have slightly different one. It will be mostly in your file and settings, but you can find it out. Preferences, PyCharm, and here you can see these behaviors and appearance, where it talks about font size and everything else, all for the entire PyCharm. And this is for editor. Editor is a space where we gonna write a code, right? So again, it also has a font and many other things, color scheme. There is quite a bunch of things which you can actually go ahead, play with it and figure out and set things for your convenience. For project related, you can go to this one, the PyCharm project. All right, you can click this and you can see there is a Python interpreter in which you have this the setting button. Remember, we have created a new Conda environment. You can see that it shows that we are using the PyCharm tutorial. That's the environment we have created. So we do not have any other environment. This is a base one, but you have created a new one. All right. So anything we install, it is stored in this PyCharm tutorial environment. So that's really important. And you can change it if you want. You can even create a new one and add it, but I'm going to leave it like that. Okay. So that's about your the settings and stuff. And coming to the bottommost thing, this is where all of your things show up. There are 4 things, as you can see. The first one is to do and is run, and then terminal, and then Python console. All right. Let's start with to do. To do is actually a very nice feature. I really like it. I use it all the time. This gives you a kind of notepad, a scratch pad to write down certain notes where you can come back and check. For example, I'm writing some function, right? Any function. So I'm writing some function, define a process data, something like that, and I have written something. Print as something else, just testing, or hello. Not bellow, hello. Okay. And then I thought it would be nice to actually add a parameter to it. Maybe a data can be passed down to this, like data. So I don't have time now, or maybe just an idea. I can put a comment here and just type in to do. You can see that the to do has changed the color. It went into kind of a green color, right? And then I can say function can take parameter of data as a parameter to be completed. Okay, so that's the idea for the future. So when you do it, maybe another to do somewhere here. This function is incomplete. All right, so this function is incomplete, whatever. You can see that when I open this file in the to-do section, I already see there are 2 to-dos, like things to be done here. And you can just drill down to that, and it can actually show you the line number and the location where this to-do is. And you can actually click and it goes there right away. And from there, you can start finishing the work which you left incomplete. This is a very nice feature, especially when you're developing a sizable projects. You really have to make notes many places in the code, because you're not going to write in one go. You always write in phases, and whenever you're doing a coding, you get some great ideas. And it's best to write the ideas there itself by using a small to-do function. Run. When you run the code, this is where you run it actually. So if you just click this one, it's going to run it, and you see that there is a mistake over here. We don't have a NumPy. So it says that no modulus NumPy, but this is the result. So obviously, when you run it, you look into the run window to find the results. The third one is terminal. This is very useful function because you don't have to go to the command prompt anywhere else. You can actually access your terminal or a Anaconda or Python command prompt directly from here. For example, as you can see, this is currently the environment is PyCharm tutorial. All right, so you can check the environments, like what are the other environments available right from here. I can say Conda environment environment list. So I only have I have many environments. Okay, that's great. So we have base environment, which is when you install, you get one base environment. And then currently you can see a star. This is the environment which is live. I also have a YOLO. I would have tried something before. I have TensorFlow 1 environment, TensorFlow 2 environment. TensorFlow really, if you are using a project with TF1 and TF2, TensorFlow, they are completely different. TF1 does not really support an interactive. It does have an eager mode, but it's quite complex. TensorFlow 2 version is almost like any other Python modules like sklearn or whatever. So obviously, there are packages which are developed in TF1. If you're doing or using those external packages, you should have a separate environment. And they do not go together well, though there are tweaks, but so it's better to maintain. So there are like different environments. You could even activate the other environment right away from here by saying Conda activate. Let's say I want to activate YOLO. You see that when I say YOLO, you can already see that my command prompt has changed to YOLO. All right. Also, this is getting reflected over here, so I don't want to do that. I'm going to come back to, I'm going to come back to my, what is that, PyCharm tutorial. So I'm back to my tutorial. I can clear the screen, and you can do pretty much. For example, I do not have NumPy, as I can already see. I can install NumPy right from here. I can say pip install NumPy. All right, and then it takes maybe less than a minute to install it, collecting NumPy. And now NumPy is installed. Now you go to your library here, site packages, and you should be able to see NumPy. Here we go. Because now you have NumPy, when you run it, this time it should not show any error. So there is no error because NumPy is now installed. So you can do all kinds of command prompt things or command line things like installing stuff or changing the environment if you want to do it manually. Everything can be done from inside your PyCharm. And the fourth one is Python console. It really comes into picture when you want to do an interactive way of doing things. For example, the similar way what you do in your Jupyter notebook. For example, I have something like, let's say, so I'm just going to use print commands. Hello, this is code 1. And then I have another print. This is code 2. I'm going to also print some things like a is equal to 3, a is equal to 4. I'm just overwriting the same variable. All right, I'm going to print a. All right, cool. I've just written some completely meaningless piece of codes, but just to show you, right? I could literally select a piece of code and run it. Very similar to what we do in Jupyter. You write Jupyter notebook. We write certain things in a cell and you run the cell, right? The similar manner, I could actually select this and press Control Alt. Control Shift E. And then it runs the piece of code, just this piece of code which is selected. So just to give you a a side note, to run you can press Alt Shift plus E to run a select code. This pretty much makes your PyCharm like your Jupyter notebook. So if you're transitioning from Jupyter notebook, or most of the people use Jupyter notebooks, so this feature, this shortcut key is really useful for you. Okay, so I'm going to run this one now. I'm going to select that one. I don't have to select the comment, but anyway, Alt Shift and E. You see that I have printed code 1 and the 3 is actually the value of the A. Interestingly, if you look at the variable side of it, it will display all the active variables. So it says A has a value of 3. Now I'm going to select this code and run this again using Alt, Shift and E, and you see that A has been overwritten into 4, as you can see over there. Okay, so it's very convenient. You can see all the active variables, the variables which are in memory with their current values right in here. And also the special variables, like there are multiple special variables. Name is a special variable. Essentially, name always contains the name of the function we have right now. So it's not that simple. So name is a special variable. So when you're running any file, that particular file will become the name function. But anyway, so this is not, like you can see the system variables and special variables, which you may not be interested for now, but these are the variables which you are declaring and your program is actually using the current values in it along with the type. So this is very helpful. All right, so that's a quick rundown, and yeah, a few things I would like to say. I'm going to stop this one. So when I do it, it actually stops it. And I can also go ahead and set what we call as breakpoints. I want to see how are the things still here. You just take your cursor here and just tap it like this. You have to go to the debug mode. So I go to debug mode, and then I'm going to simply tap things over here. So debug mode process is connecting. Okay, all cool. Okay, I want to enter the debug mode, so I don't have any. Set a bookmark. Okay, let me check. Okay, you go to the debug by just pressing this debug button over there, and then it enters into the debug mode. And you can say you have debugger and a console. Console is an output, and debugger is the debugger, right? So here I can actually set what we call it as when I go to the debugger, it's actually stopping that one, so understandable. Oh, I can, of course, I can only create a debug or breakpoints, we call it breakpoints, where there is a real code. I didn't notice that. So I just created one here and one there and maybe one, let's say here, all right, maybe here, all right. The benefit of this one, when you run, I can run by steps. You can basically, there is a, you can go to debugger, and then you can simply say, okay, I don't want that. You click on this on the breakpoints, it will simply you can remove it, and you can add and remove by simply clicking here. That's really convenient, right? Then you go to the debugger, and then it stops automatically here, as you can see, and and then there is a small button here. Go to the next breakpoint. So when you resume the program runs, and it runs till the next breakpoint, next dot point you have over here. So, and it stops over there. You can go to the console and see if anything happened. Of course, there is nothing printed out because it's a function, we haven't called it. And then I'm going to do one more this thing, and you say, and you see that the control has come to here, but this has been printed out, as you can see here. Then I can do this, and it basically completes your debugging. So you can actually get into the debug mode, put multiple breakpoints, and simply run your program till that breakpoint and do it. And this is really helpful when debugging. Something went wrong, you don't know where it went wrong. So you could actually stop the, you can basically go into a debug mode and run the program till the breakpoints and in steps, one by one by one. And you could figure out the mistakes and fix it much easier. All right. So these are the key tools you have. And I think this is good enough. There are a bunch of other tools. You can go here, we can refract the code. We can, code folding, for example. When you write a big codes, big linear codes, I want to, let's say, just have, let's say, too many things over here. It might look very messy. And I would like to just fold all of these things. I can go here, select this. I can go to the code and say folding. I can expand, fold, collapse recursively. Right now I'm using the fold selection, right? And you can see that it got folded. I can unfold it, unfold it. So that actually, when you look at the program, you can see that things are much more cleaner. So it's all folded up, and you can unfold it when if you want to change something. Otherwise, you can keep it folded so that you have a good visibility, good readability of your code. I think that's pretty much it. And we can also create more folders over here, organize our code. For example, we can create a folder for, let's say, data. and we can create a folders for let's say models, the binary serialized files, and you can also create code folder for scripts source, we can call it, and all the Python scripts can be put in over there. Well, and you can organize your files in these folders nicely. So this is a quick overview of PyCharm, and this is actually good enough. When you start doing it, you explore things by yourself. Okay. There are many shortcuts, by the way. For example, one of the shortcuts I already told you is Alt, Shift, and E, which will run the code, the selected code, which is really helpful and kind of makes your PyCharm more or less look like a Jupyter notebook. You could also press Shift 2 times, Shift key like 2 times, tick, tick, and then you get a universal search. So you can search anything in it. So I want to search, let's say, process data. There is a function over there, I can already see it, but let's say I don't see it. I can say process data. So it clearly shows you there's a process data function in the main. You click it, it goes there. It's interesting, right? You can also actually run commands. For example, actions. You could go to actions and say, I want to debug, for example. Well, you can also click the button over here, but somehow I could not figure out. Then I say debug. So it says debug. It also says I can press command and 5 to debug it. It's a shortcut. Or I can simply debug the main, right? I can click it. It runs right away. So now I'm in the debug mode, right? So 2 times pressing shift, you can literally do anything. You can find things. You can refract things. You can find symbols, files, classes, functions. You can also find and run the command there itself. So shift and shift, 2 times shift is really helpful shortcut for you. All right, if you click outside, it disappears. I'm going to stop this debugging mode. So that's a quick overview, right? You don't have a pandas, so I can also install pandas and other things right now. This is so that completes your first 3 things: why PyCharm, installation, and overview. I did not go through the entire, the features of PyCharm. It's quite comprehensive, but let me tell you, if you get started with the things I have introduced to you, you should be good enough to explore by yourself. You don't need to read the entire thing, right? You can actually figure out things by yourself. Let's do a quick project on PyCharm, and then you appreciate. So I'm going to close this project right now, and so I have uploaded a small use case in DataMites public datasets. Git repository. There is a test CSV and train CSV. This is about Bangalore house price. I've taken a very simple use case. We are trying to predict house price or apartment price in the city of Bangalore, right? It has the area and the location, and I don't know how many bedrooms, balconies, and stuff like that, location, stuff like that, and then you have a price. So it's a regression problem. I've chosen a simple problem because I want to introduce PyCharm. So the goal is not to teach you machine learning modeling that I assume that you have or you're already in the process of learning it. PyCharm, I want to introduce PyCharm. So I'm going to take this small data set. I can right away go here and import this. Select this one, say code, and say download this zip. Just double click it unzips, and then you have okay. So Bangalore house price is a project I'm doing. For that, let me create a folder like the project first. I call this project as Bangalore underscore house underscore price. All right, and I can create a new environment, or I can just use the existing conda environment. Right now, I'm going to simply leave it like that. Oh, I would have used the existing conda environment. That's okay. I said every project has to be done with its own environment, so let me stick to it. It's just that I need to install many packages. That's something I need to do. Okay, so inside that, I'm going to create multiple folders, right? First is data, and then I have the script files. So I say source, src, and then I have models. We can also create notebooks. Well, we might also have some notebooks. You can create notebooks, reports, evaluation, and we can create external libraries, folders. We can do many things, but these are three important things. Data, models, where you store the binary serialized models. After you train the model, you dump the model into this folder, and source file where you have all the scripts being written. Okay. So inside the source folder, I'm going to create a file called, let's say, train.py. Well, before that, maybe I should create something called as data processing, or I would say feature generator or processing. You can give any name you want, .py. All of these files are Python files. It's a simple, like plain text Python scripts. Okay, and adding the configuration. So I'm going to go click add configuration. Without adding configuration, it will not work. So I'm going to just browse. I'll take train. So in the source file, I'm going to take the train as a key file, and interpreter is fine. Everything is looking okay. Let me see the packages, what I have. So I have only the basic ones. So anything I need to install manually. All right. So I could also change, but that's okay. Fine. So I'm going to copy. Look at my reveal in a Finder. So that's the folder. Inside that, I'm going to copy these two files which I have just downloaded from the Git repository. I can also pull it directly from Git repository. I'll show you that. So right now I'm going to simply paste it. When I paste it, you can see already in my PyCharm that both the files are over there. Okay. I'm also going to create a small file called config.py, where I can store the variables like the path of the train file, test file, models, etc. So for now, I'm going to say train data is equal to, where is it? It's in the data folder, data, and the file name is train.csv. And I can do the same thing for testing as well. If anything is needed, I'll just come and add in the config file. All right, so I'm going to quickly jump into, first we'll start with feature processing. Okay, so we'll import the data, and then we'll start, creating, processing the data, looking at the missing values, imputation, and also doing some label encoding. I'm not going to do the entire feature processing. Like, you need to look into outliers, you need to look into normality, correlation between the variables, and many other things, and also put a lot of business sense. I am not going to do all of them. I'll simply do a imputation, which is anyway required, the missing value treatment, and then label encoding. So I'll stop there. So I'm going to say import pandas as PD, and if I just run it by using Alt, Shift, and E, it's going to tell me that we don't have a pandas because we created a new environment. So just import pandas. I would have done, install pandas. I would have used the base package. So all the things will be already over there. But let me teach you the best standard method. So it's always better to create a new environment, especially when you're working in a production project. For simple small projects, you can use your base environment. Okay. So I have installed pandas. When I run it, it will simply tell me that the pandas is imported. There is no error, as you can see. All right. I am going to go ahead and stop my debugging mode right here, the interactive mode. Go here, change the this thing, and then okay. Edit configuration, and so I'm going to go back to the default Python interpreter. Okay, and also let me go. I'll show you another way. If you go to preferences, if you go to the project is much more like standard method. You can see all the all the things. I'm going to go back to the standard. I'll say OK and say apply and click OK. All right. And now if I look at my external libraries, side packages, you will see everything. So this is the base package. You will see pandas, sklearn, and many things. I just don't want to waste a lot of time of years by installing everything, which you can do, but I'm switching to the standard environment. So that's actually better. And then, let me import the config file because it has the path of your test data and the train data. So I'm going to first import config. I don't find it. It's config, right? Yeah, it's in the same folder. Oh, okay. So we need to say, of course, from src, which is the kind of module here, a folder, import config. Okay. So that will ensure that you imported the config. Now I'm going to quickly go ahead and import the data. So I'm going to call it as data frame df and pd.read csv. I can say config dot train data. Let me quickly see head, of course. So let me quickly see if this runs. All right. So I'm going to select all of these things. I use Alt Shift and E, and what's happening? So let me restore it. You click that, it gets restored. Now I'm going to select again and say Alt Shift and E. Okay. So we got the data. Excellent, and there was no problem at all. It's pretty straightforward. And the beauty of PyCharm, again, you also see the variable as a data frame. So you see here the corner, you have this view as a data frame, and there is a variable called df, which is just what we defined. Click that one, and that's amazing that you can see the entire data frame with all the columns. And well, the color coding is, it's essentially, it will take the highest number as a red color and the lowest number as a blue color, and everything between is like a gradient from red to blue change. All right. Sometimes it makes sense. You can see that this is actually pretty near to the highest. It's to balcony is like most frequent, and this is one of the near to highest. These are all like nominal blue colors, but you can just click here saying colored cells. You can uncheck that. Everything becomes a simple text. I think I actually prefer this. So you have area type, so build up area, or it's a super build up area or plot area. Availability, is it available ready to move, or is it available on some date, right? May, something like that. And its location. Society is community, and this number of BHK. BHK is bedroom, hall, and kitchen. So it's 2 BHK means 2 bedrooms, and then a hall and kitchen. And then you have an area in square feet. And there is a number of bathrooms and balconies, and the price. This is a Bangalore house price. So I assume that the units of this 32.25 is Indian rupees in lakhs. Lakhs is 100,000. All right. So it's 32 lakhs, 32.25 lakhs. All right. So I can see all of these things. The next thing I would like to do is to look into my information of this. Again, I press Alt, Shift, and E, keeping the cursor, so that will only run that line. I can literally just resize the bit and go and look at this. So I have some columns. So the total number of data I have is 5008. Okay, it's not a big data set, it's a small data set. In that I have area also have 5008, which means it does not have any missing values. Availability also does not have any missing values. Location also have no missing values. Society has quite some missing values. BHK also has actually 2 missing values because it's 5006, and square feet does not have any missing values. It's a good thing. And then bathrooms has some missing values, about 10, 15 or something like that. And then balcony also has some few hundred missing values. Price, of course, it's a target variable for us. It has all the values. So I see that society and bathrooms and balcony have missing values, and BHK has 2 missing values. Let us first fix the missing value problem by using imputation. So I'm going to replace the missing value by fill missing value, fill NA. I'm going to just call this as feature imputation. Usually we do it like one feature by other feature because it's not a machine learning project. I'm more teaching a PyCharm for you, so I'm going to do it as one go. All right. So let me first do it for society. So obviously, if you don't have anything in society, I can maybe replace it with saying no society. Right? That should be good enough, isn't it? So df dot society dot fill NA, which essentially fills the missing values. I'm going to say no society. Basically, it does not have a society. Maybe it's an individual house or something like that. All right. And then I'm going to say in place is equal to true. I'm asking it to replace it right away. Right. Let me look at my society over here. Let me see if there is any. Yeah, there are a lot of societies which has nans here. See, I'm going to run this small line, keeping my window up. So okay, let me just bring the society over here. So you can see the society, there are a lot of nans, and I'm going to just click here. This window anyway stays at the top, so it doesn't go at the background, so it's very convenient. I'm going to click this one and say Alt, Shift and E. There is no errors, no errors. So you can see that all the nans has become no society. Because this is an active memory, it's showing you what's there in the memory in the variable. You can literally real-time see what's happening to your data frame when you're executing certain things in PyCharm. So my society problem is now solved. The data has been, the missing value has been replaced by no society. That's cool. And then I'm going to do it for BHK. So I'll say .bhk .fill NA. If there is no, I mean, there won't be apartment without any bedrooms. Possible? Yeah, could be possible. So I don't know. There's only 2 actually. I don't care. I'm going to put 0. All right. So I'm going to put 0 for wherever missing value is. Only two records like that. So I'm going to say in place is equal to true. Just run it. Shift, Alt, Shift and E, and yeah, it got replaced. It's difficult to find it. Somewhere some missing value is replaced. So next you have bath. We have about 10. How many? 9 plus 6, 9 plus 8. 17 missing values in bath. I'm going to simply say you really require one bathroom, isn't it? So one bathroom is, so I'm going to literally put one here because someone with one bathroom didn't really bother mentioning it. So I'm going to say replace. Well, that's important to remember. I'm using my common sense over here, right? Why I'm putting one bathroom? Because I know that you should have a bathroom in a house, in an apartment. This is one of the reasons why a data preparation or feature processing or whatever you call cannot be automated. So there are many people think that if everything can be done in machine learning, why can't you simply automate everything? Why you need so many people in data processing and feature processing and stuff like that? Simple reason, this requires a human sense, common sense, and of course a business sense. And this cannot be automated. It's a good thing. So we have jobs. So we have many jobs in data engineering and feature processing because this requires human sense. So I know we need a bathroom, so I put one over there. And then I'm going to just run it Alt, Shift and E. Somewhere it got replaced. And then balcony also I'm going to do it. So, well, again, I'm going to go with a bit of common sense. I don't know how useful this is because I'm not going to check this, whether these assumptions, what I'm doing are correct. That's in a normal project, we do that, right? We try different ideas and see which idea is giving us better accuracy, better fitting of the model. Right now, I'm not going to do it. I'll put 0 balconies. There can be apartments without balconies, of course. All right, and then run it. So all my things are replaced, and then I'm going to go back here saying df info. I'm not writing it again. I'm just going back and simply going to run this Alt, Shift and E. This time I see that all of my variables have no missing values because I have taken care of it already. Great. So the next thing I could do is label encoding, because these are all categorical data. It has some labels, area type, location, and society. All right. So fortunately, all of our variables are actually categorical. First 4 are actually our categorical variables. So I can simply replace them with labels, label encoders. So I can just give a number for each of these things. I'm going to say label encoding. categorical variables, encoding, label encoding. Why it's showing something? What is that? So reformat a file. Oh, that's okay. No issues. So label encoding the categorical variables. For this, I could actually do. I can create a bunch of label encoders because I need to remember which column. Essentially, when I label encode, I need to have that label encoder remember which data got what number for every column. So it's always advisable to create a list of label encoders to do label encoding for individual things. So I'm going to create, first I need to import the label encoder, which is from your sklearn. So I'll say from sklearn preprocessing import label encoder. Okay, so that I'm going to just run it there itself. And then here, so let me first create label encoders, kind of like a dictionary, an empty dictionary, okay, and then run a for loop. So I'm going to take individual columns. So I can literally write down the column names. I can also take it from this and take a slice of it. I'm going to right now keep it simple. So I'm going to say area type and comma availability comma location and then what society. Okay. That's good enough. So that's a for loop which is going to take area type, availability, is a spelling correct? Okay. That's most of the time where I go wrong, or many people go wrong, is just typing mistakes. That takes a lot of time. So this it looks okay. So I'm going to say label encoder, and then inside that I'm going to take this C, which is that the first one is equal to, and then I'm going to simply create an object of label encoder. Okay, so label encoder, so which is actually imported over here. So it's going to create an object of label encoder and store it in a dictionary, and then I'm going to do a fit and transform. So I'm going to say df dot area type, or df, I'm going to use the same column, C is equal to, and this entire thing, that's the label encoder I created for this fit and transform. Okay. Fit and transform, obviously, and then I'm going to just send this again. Okay, normally never it runs without error. Let me see if it runs without error. So I'm going to select this entire thing and just run it, Alt Shift and E. Okay, label encoders are not defined on. Just also copy this, Alt Shift and E. Okay, seems it has run. Wonderful. So it has run, and I don't like these colors. So areas has been label encoded, availability, location, society. So everything is label encoded in one go. Great. And the beauty is we have the label encoder as a list. So you can use the same label encoders for future data. So without again fitting it, we can only use transform moving forward. All right, so we are done. So that's about your feature processing, right? And then I just have to store this data into a file, and then I'm done, right? That's what this particular file does. So I'm going to simply say df dot to CSV. So let me create a new variable over here, and that variable is called as train processed data, and the name of the file would be same, but I'm just going to add a small processed underscore processed. Okay, small file names should be always small letters. Processed. Okay, and you can put anything you want. I mean, I can also do the same thing for test as well. So when we do the test, then it is more consistent. And then, all right, so this is config. Actually, you don't have to run it because this variable when you run it gets. So here I'm going to say config and then process data. So because that is taken from there, so this is done. And I'm also going to store, again I go to this one, I'll say model model folder. So basically model path, models path, that makes more sense. So that's actually models, isn't it? So that's the models, and then that's actually good enough, and I can just add whatever I want to do in there itself. Okay, so I'm going to export the label encoders also, because if I want to use it in predict or evaluation, I have to use the same label encoders. Why? Well, it's pretty simple. If a society got a name as, so you can see 723 is no society. That's something we have replaced an and with, all right? This is some kind of society. I don't remember it, right? So when you do a new data transformation, this society should, whatever it's the society over here, should also get the same 1008, right? The same label. Otherwise, it makes absolutely no sense, all right? So the label names, the names and the label numbers has to be consistent. That's only possible when you also store the label encoder module, so that next time when you have a new data, you simply use transform, not fit, all right? So I'm going to export this. That is that. All right, so that's label encoder. So I'm gonna, for that you need a library called joblib. That's the one you can use because joblib is more nice. So that's the one which is used to export the models. So I'm going to say joblib dot down. Why it is not coming? Not from joblib, and then simply import joblib. See, you would have already observed that the speed at which the this completion of auto completion pulling the information of the module is really high. As you can see, it's instantly coming in. So I want to dump it. So click. So it's pretty straightforward. All right. So what I want to dump the label encoders. That's actually a dictionary which contains the name of the column as a key name and the corresponding label encoder as the value. Right, and then I'm going to give a name to it, and it has to be in your config dot models path. Then I can just give a name, for example, feature encoders dot pickle. So these are all serialized. You can use PKL for it, and that's it. I'm going to simply stop this entire thing, and then run this file train, like feature processing, just like top to bottom like a normal run. All right. So I have to just looking at it. So everything looks perfect. So we have did the imputation over here, and then we have done the label encoding with a simple for loop, and then we simply store the process data into the file. This is actually not test, sorry. This should be train, isn't it? Yeah, train process data. Yes. Okay, train process data, and then you have also dump the feature encoders. Let me run this. Just alternate click here and say run feature processing. I have some problems, and the problems are okay. what was the main problem? File not found. Why? So the file data train.csv is not found. That's when we are doing manually, we could find it. Now let me just do it manually here again. Stop everything and just run this Alt, Shift and E. You could find here when you're doing interactively. So what's the problem with finding when I'm doing it as a full run? Oh, okay. So, well, just have to give a relative path over here for when you're running there, because it's one step. Like this file config is in your source folder. To go back one, let me first check if it works. If it checks, then it's cool. Otherwise, I have to find another fix. It works. So I have to mention a relative path. So basically, I have to go one step back over here. One step back because I'm in a source folder. I go back to the root folder and then come to the data folder, then give the file path. So these are things which keeps on coming in. So this should be figured out interactively. So as you can see, when I run it, there's a new file being created called train process. You can just right click and see that. So it's all numbers, nicely cleared, no data problems. All the missing values are taken care. So this is cool. And also in the models, you see that there is a pickle model which says feature encoders, which has been also stored. So our feature processing is ready. To make it more nicer, I can actually put everything of this into a function. So the way we can do that is by simply selecting all the code which goes into a function and press a tab. So that gives an indentation. Above that, you can simply define something like def feature processing process, all right, and then put a colon. And well, you could actually take this as a as an input like data, and from outside when we call it, then we literally pass on the corresponding things and it will use it. So what I mean to say is, from any other place you can actually call this function from this feature, and automatically when you pass the data, it does all the cleaning what you have just done now. And we don't really need all of this, because now that we can clean up, that's only when we are trying to understand what's happening. So we don't need any printing, nothing. So we simply take the file, do the imputation, do the the label encoder, and dump both the clean file as well as the binarized model of your encoder. That's pretty clean. So that's your first one. Now let's go to the train and do the the training of the data, modeling of the data. Again, I'll start with from src import config. So that's a file which contains all the the paths and variable things. And is a linear model, so it's a regression. So I'm going to use linear regression or maybe some other regressor, random forest regressor for this. All right. So I'm going to import from sklearn linear model, import linear regression. Also, I'm going to say from sklearn run ensemble technique and import random forest regressor. All right. So these are the three things, and then I need to import the data, which is, so I'm going to say data or simply df. I can say train as well. Train data are not required, so we can say df first. Okay. So df, and can I import the pandas as well from import pandas as pd dot read csv, and then you have okay, you have to mention config dot process data, because it's anyway the file name is there, so you do not have to worry about finding it. So you can simply use the process data, and then Right now I'm going to run it in interactive mode again. Select all of this, press Alt, Shift and E. You can see that the variable actually, I can just go ahead and see that. Yeah, it got a little slow. So it's actually loading the values because there's already quite some values. Let me cancel this. Go to my feature processing, stop everything. So I'm going to stop this. Okay, great. This is not required. This is anyway a simple file. Okay. No, it should actually display this. Okay, I'm going to simply do this again one more time. Restart it. The interactive mode. Alt, Shift and E. Select it, Alt, Shift and E. Okay, there is some problem. And the problem is, so when you're running in interactive mode, the file isn't really getting accessed. So this is a bit of problem. So I'm going to run it directly. So I'm going to run it like run train. Okay, so I got the data and all the data are pretty clean. So, oh, I see that there is a new column being formed. This is because that, oh, I understand. So when you're exporting the data, see there is a, there is no header like this comma, there is nothing before. This is not nice. Let me go to the feature processing. When I'm dumping it through CSV, like this, I have to also say index is equal to false. So it does not create a new empty index thing, right? So I'm going to delete this. I don't have to delete. I can simply run this one more time. And then I have to call it from here itself, because now it's a function. I have to call this as what is that? Feature process. Okay, and then I have to pass the data. What is the data? Config dot the raw data, train data. Okay, now I'm gonna run this feature processing one more time. No problem. So it's got run. So let me see if this file, now you don't have that. See, there is no comma there, so the index is not there now, which is great. Now let's come to the train, run the train one more time. I can even select from here and run it. Run the train. Great. So now you can see the first column itself is area type and availability, and everything is in numbers. No problem at all. Just to be sure, I want to also look into the info part of it. Okay, so everything is in numeric, so there is no object or anything like that. So integer, 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 all four, and then you have a BHK, square feet, and everything into a float. So perfect. So we have things pretty straightforward. Now we can move ahead and do the modeling. For that, I'm going to use. I'm going to define something called as models. All right. So here. I'm using a dictionary so that I'm going to try multiple models. I have linear regression, I have random forest regressor. I can define any number of things, neural network for example, right? Support vector regressor. I'm going to create a dictionary saying that linear regression, that's the key name, and the key object is simply linear regression. Right? I'm not putting any parameters. So and then I say random forest. And then I'm going to say random forest regressor. It requires a parameter called n estimator, otherwise it normally throws some error. So I declared a dictionary called models. The reason I have done it, so I can actually swap. I mean, I can define a variable here called as model, for example, and I can set this as, let's say, linear regression. Okay, so whenever I want to run a linear regression or random forest, I can simply change in the config and run the entire model. It automatically picks which algorithm to be used. Now I can go ahead and do the data part. So I would like to split the train data, the data into x and y. So my x is equal to df, all the variables. Okay, just what happened to my availability. Availability isn't really good because it has got, that's okay, that's fine. So for now, so I would have done something better with availability. So because there was ready to move, and then you have individual dates. The dates can be taken as not available, and individual ready to move can be taken as available. And I could have done something like create a nominal variable, something like is ready, and then essentially put 1 for ready to move and 0 for some dates. That actually makes model more better, but that's okay. I'm gonna just do it right. I'm gonna say ILOC, and I'll take all the variables except the last one. Last one is the price, and then y is equal to df dot price, right? And just let me look at my head. All right, and run it. Run. Okay, so as you can see, I have to print it. So if you don't print it, it doesn't come because it's running as a full program, not in interactive mode. So you can see, yeah, so I got it. So everything is there except your the price thing. Okay, great. And okay, so we can actually train. Before that, maybe I could go for I can use a simple 30-70 split. Most people use the beginners, or you can go for cross validation. Okay, I will go for simple, very simple 30-70 split. I'm gonna split the data into, I'll use one more. From sklearn, we have model selection. Can go for cross validation. It's actually simpler, but let me just stick to train test split, which is a tiny little function which can be very helpful. Train x test y train y test is equal to train test split. You can pass an x and y. You can say random state is equal to some number 10, and then test size is equal to 0.3, 30% size. All right. And then if I run it, automatically my data is split into train and test, and then I can go ahead for modeling. So I'm going to say model is equal to or here I can literally use models and then specify what is there in your config. So config dot, let's say, what is this? Okay, what is there in the config? I only have model, it's showing many things. Okay, config dot model. If I specify linear regression over there, so obviously the linear regression and this module will be attached as a module. All right, so model, and I say model dot fit as we normally do. So we'll say x train and y train, and then when you want to evaluate it, we can simply say predict is equal to y predict is equal to model dot predict, and then I can pass on x test. And just simple example. So I'm going to also do the evaluation here itself. I'm going to import from sklearn metrics, import R2 score, okay, and then I can literally print auto score here, print auto score y test and y predict. All right, cool. So let me run. If it runs successfully, then I'll explain you maybe a bit slower. Oh, it did run. So we got 84%, which is very good. And what I've done here is pretty straightforward. Okay, let me also check another one. I'm going to change this into random forest, and now run it. Now run it again and see how this time it runs. Previously it was 84%, and this is 86.6%. That's expected. Random forest regressor actually works better than a linear regressor in this kind of problems. Okay, great. So so this is your train, and I can actually make this as a as a function again. So I'm gonna select all of this and press a tab to give the indentation. I'm going to just type in def train. Okay, and then again I'll take data inside this. I can put the same data over here, so that whatever data you pass on will come over here. And I don't need any printings, because that's only when you're trying to model it. Once you're sure that everything is fine, you simply remove all the printing. You can keep the last one just to see that. Okay, great. So this is your train, and I can literally call the train here and pass on the data. Data is config dot train process data. I simply run this one. You can see that it runs, and okay. So I can also say something like config dot which model we use. So this is model, and come on, put some space, or maybe a column and then a space, and then random forest accuracy, and then some space, and then I can take an R2. So I'm just trying to make it more nicer. So it's going to say which model is that. So it says its random forest accuracy is 86.56. Let me change this into, let's say, linear regression, and then run the train again. It says linear regression accuracy is 84%, so it's very consistent with what we have done. Oh, excellent. So this is how you can do it, and well, you can also write another file called predict. And there you can use test data to predict.py, and there you can actually do the things whatever you have done in the train, but this time try to do it with the train data. You take the train data, you process it, and maybe in here you can actually, in the feature processing, you can actually give another label called as mode, where you can specify whether it is a train or a predict. Because when you say train, we do a label encoding as fit and transform. When you're predicting, we use the same label encoder, so we only use the transform, right? Here, you could simply use a if condition, saying that if mode is equal to train, then you do this. Else, okay, what's going back? Else you do only the, okay, else you have to okay, so else we have to import, so we need to have a job lib for that. Job lib is already there. Okay, so we have to say label encoder is equal to job lib dot load, and then you say config dot model path. So models, not models here, models path, and then okay, I have to add it. Then what was it? It is what was the name of it? This one, the feature encoders.pkr. Feature encoders.pkr. All right. So what happens? It checks whether it's a train or a predict. So if it's a train, then it will actually, create a feature label encoder with fit and scratch, completely new, and store this thing over here. And well, again, here also we have to do the same thing. So we have to say okay. We have to say if it is train, then you dump it. All right. Otherwise, not required, because we are simply using it. So, all right, great. So this mode needs to be given. So when you're calling the feature, you have to simply specify whether it's a train or a predict. So here, when you're calling the feature processing, you can simply do that by saying import feature from src import feature processing. All right, and then you can say feature processing dot feature process, and here you can say config dot okay, so I need to import config as well. From src import config, and here you can say config dot test data. That's the data we want to give, and then you have to specify as predict, or I mean you can just predict or something. So when the feature module, this function is called from predict, then it will simply take the existing feature encoders and use only. Okay, we got this, and we simply gonna transform using the same thing. At this time I'm going to do like no fit. That's all. So it's simply gonna use the same thing and transform, so without fitting it. I think you understand. So this tutorial, I hope this given you a perspective of how to do things. So when you have a new data, you want to test it, you can use a predict. You know, if predict, you can also simply write some modules to export the predicted output into, maybe you can create another folder called as outputs, predicted outputs, and you can store it there. And you can, you know, based on your project requirements, what kind of projects you're doing, you can change things and you can use it. I'm going to upload this entire, whatever I've done, partial coding. I haven't finished the predict, but I'll just put it in your Git repository so that, you know, you can access it. And this is definitely not the standard coding ways. I want to introduce you the PyCharm. So you have to do a very comprehensive feature engineering, feature processing, and many other things. So this is just to tell you how to use the PyCharm. Also, when it comes to your the folder structure, you can also create for data, you can create a folders like raw data, where you can store all the raw data, which is not, it's not supposed to be tampered. We never change anything in raw data. Then we can have an interim folder, where it's an intermediate folder where you have partially processed the data, still some processing is required. Let's say you have done some imputation something, and then you have to do some more, I don't know, transforming the data into different or maybe derived variables and stuff. We can have an interim folder, and we can have processed folder. We can also have a folder called external data, where you are importing data from, you know, external SQL or some other external sources. You can put it on here. So this could be your data folder. In the similar manner, SRC can also have, the source can also have multiple subdirectories. Like you can put all the scripts which is to do with the data processing, feature processing into the data. We can do all the modeling related things into the modeling, and evaluation into the evaluation. So likewise, we can also have subfolders in your source folder, and you can basically organize your scripts based on what kind of script it is. Is it data preparation or data processing? You put it in the data, etc. Models, it's okay. You can just have one model. You can put a meaningful name to it. So that's all. That's about doing a quick project in PyCharm. And you can see that I can literally change the file names over here. If I get a new data, I can literally change the file name here, and everything else goes absolutely fine. I don't have to do anything. I'll just go to the train and just run it. Everything is taken care. I can just, you know, change the model here, and it goes. For example, I want to try with support vector machine, for example. All right. So I can just go to the train and just add one more thing over here called, let's say, comma. I'll say SVR, support vector machine regressor, and I need to import that, of course. So I'm going to say from sklearn svm import support vector SVR actually. So that's support vector regressor. All right. So here I'm going to simply say SVR. I can put some parameters. So SVR has parameters like, let's say, kernel is like RBF, non-linear. All right. So I can also put gamma value, C value, and other things, but I'm going to leave it for default. And now if I go here and simply change this to SVR, is it SVR? Yeah, SVR, and simply save it and come here and run it. So there's some warning, but that's okay. But you can see that, oh, there's a very poor accuracy. Something went wrong. Yes, we are. You need to do a scaling. I haven't done any scaling, so even though I don't see why the value is so low, but you can literally see that you can run it. Say SVR accuracy is this much. I'm surprised to see that. Auto score, so it's not accuracy. Oh, I'm sorry, it's actually auto score. My apologies. That's not accuracy, it's auto score. Auto score is a relative score. You're comparing the performance of your model with the mean model, so that's completely different. So random forest is 86. Anyway, so I think you got my point. So you can just change the configuration here. You can change the model name. You can also give a model name over here. You can do many things here and simply run it. So this is much more cleaner, much more modularized. I haven't used class and OOPS concepts. If you use them, it becomes much more controlled, modularized code. And with PyCharm, you can deliver any sizable project, and so that's the benefit of PyCharm. The last topic we have there is about GitHub Repository. So if you go to VCS, you can actually connect to a GitHub repository. So let me just enable version control integration. So I just click that. It's going to ask which version control you're using. Obviously, you're using Git. If you're not aware of the Git and GitHub, my previous video I uploaded in DataMites channel is on Git. Right. So I'll leave a link in the description. Just go ahead and watch it. So Git is the standard. It's already connected to my Git repository because my folder is Git repository, so enable. So it's now connected. So everything I do know, for example, I change something. All right, let's say this is actually a file. So I'm going to change something. So I'll write some things like to do. I'll just write to train function needs to be parameterized. Oh, okay. Function something. All right. Parameterization. Parameters missing. Whatever it is. That's still to do. All right. When I save it. All right. So it takes it to the Git. So essentially, there is a Git staging has already been done, and you can actually go ahead and you can commit it. So when I say commit, so all the changes I've done right now are committed. All right. So I can always go back. So you can see there's a master branch over here, and I just have to write some name for this. So small, like to do note added, to do added. I'll say I just committed this. To do note added, nothing to commit. Okay, it's already committed. So it's on. And just go to here. So I can see there is a 14 unversioned files. Okay, let's do it. I'm just going to add all of these 14 files. All of the things we have just created is I just going to hit commit. So all the files which I just created has been committed. So any change we do for now is automatically tracked by the Git repository. We can also download a Git from, let's say I'm going to create a new project now. I'll say new project. Let me close this one. Okay. So you can see that get from version control, Git. All right. So you can literally click this and I can give any URL. For example, let me see if I have anything else in DataMites. Then you can, yeah, there's some project template. All right. So there is a blank template of projects like data modules, and I don't know, inside the data you have like, yeah, good. This is nice. So I want to, if you want to start a project, you don't have to create folders all by yourself. It's already like in this particular thing. Just go ahead and just take this this one URL, come here and put it over here and simply say clone, and in no time you have this entire, you can now change the name of it, but you have all the folders and everything ready. And if you're if you're using some other repository, you want to play with it, you want to download and play with it, you can simply download it from the get from the Git repository option. All right. So by using Git, you can make your code version controlled, and if you don't know Git, you have to check my previous video, then you understand. And it's kind of like standard for any coders. It takes care of version control, it takes care of navigating between the commits. It really can collaborate with your team members without overlapping or losing your work. We can also clone the existing GitHub repositories and start working from there. So that's the complete video on PyCharm. So I hope it's useful, and I did not cover a lot of things in comprehension, but when you start doing projects by yourself, you can figure out something by yourself. For example, if you want to know more shortcuts, you can simply go ahead and say PyCharm useful shortcuts, and there are a lot of people who have written useful shortcuts, and then it goes to JetBrains itself. So you can see that they've given a comprehensive list of shortcuts which you can play around. Right. Okay, so that's all for this video. If you like this video and you have any questions, please leave it on the comment. Do subscribe to this channel and click the notification button. So I'll be doing more live sessions, maybe in a few weeks time. There's a plan to start live sessions. So make sure that you subscribe and click notification so that you get alert when there is a live session or new video being uploaded. Thank you very much. I wish you success in using PyCharm in your future projects.